Good afternoon to all of you. Good afternoon to all the senior members from the fraternity and the audience right here. So I have around 15 minutes with me. I come from a company known as Sparrow Risk Management Private Limited, and the agenda is to understand the basics of AI, ML, and big data. The other two counterparts on stage have talked a lot about new technologies, but what we have gathered into the facts are quite different. That we have understood over a period of 8 years of inception that people are still not very much equipped to understand the basic terminologies to decide what actually they need into AI and ML and big data. It may be good for Honeywell and the kind of companies to have all those products ready, but are we ready for those data? For if you look at his client list, maximum of them are from the West countries, because they have the basics right. As in fraternity, we first must understand and try to grasp those technologies words, like what is AI, ML, such that you can define your need and then you can look for a product. What is happening in India is somebody is coming to you, selling their products, and then actually you're looking for those solutions that they should work for you. It should be vice versa. You should find your use cases, understand those basics, ask for funds, and get it done. So this is the basic thing around my presentation. So as far as the company is concerned, we are doing good from last 8 years. We have grown with 94% CAGR over last 5 years. And as far as the clients are concerned, we cater a lot of good clients. 80% of our clients are MNCs, 185 in total clients. So to cut it short, I'll get back to the main agenda. There's the big data, AI, ML, basic structure and use cases. It is very important for all of you, because we have seen in last 2 years as a company that everyone is talking about technology every now and then. In Hindi, when we meet a client, they say, "Karna hai, kuch to karna hai, IoT industry 4.0 mein kuch to karna hai, IoT kuch to karna hai." But what kya karna hai? That is the biggest trouble that I feel personally that our Indian industries are going through. So we are also launching our product quite soon. But before that, let's focus on the pretty basics of AI, ML, and big data. So as I said, at one time we find our EHS fraternity quite curious to use those products to understand those values, but in the back end, the same time, you don't get the feel of why those product and why those technologies. So we did a small survey to our known clients. We have 120 major EHS customers who are have very good profile and reach into EHS domain in India. And the facts and the data was quite surprising. We asked them three simple questions. The first one, you please answer yourself these questions too. This is going to be very, very interesting for you guys. Is machine learning and artificial intelligence being same? How many of you feel like it is same? Okay, how many of you feel it is not same? Okay, so most of you feel like it is not same, right? I'll get back to you how it is same or not same. The second question that we asked to our correspondent was, big data tools may use on priority what? Artificial intelligence tools, machine learning tools, or probability is quite same. They can sometimes use artificial intelligence, sometimes use machine learning. So difficult question to answer. I'm not going to ask to the crowd here. When we discuss big data, what is the data size we are generally speaking in? So what is the data size when we talk about big data, like my counterparts in the last presentation said? What is the kind of data we are talking about? We are talking about GB, the kind of gigabyte per day. We are talking about exabyte, which is EB per day. EB is, do you know what is the value of EB? It is approximately 1 billion gigabytes. So that is the kind of data actually we talk in big data. So now why these questions being raised to you from our side is, you're excited, but are you ready for it? And why you need it? It's just a thought process that will be giving to you, such that you go back to your institution, discuss with your management with a solid background that actually you need it, and this is the way you need it. And to the surprise, 10% of people said same, almost same people said 80%, and generally use independently 10%. Big data tools may use on priority. People said artificial intelligence 72%, machine learning 28%, and probability is quite same. None of them agreed to it. When we discussed big data, everyone said a GB of data per day is big data, but unfortunately it is not. The answer is B, which says in tunes of EB, exabytes. Right? Now you think that what kind of operation that you do which can create these kind of data. Now machine learning, now the answers. Now please be focused to these elements. Machine learning is a subset of AI. So when we talk about AI, it any which way combines machine learning and deep learning into it. So this is no two different things. It is when AI is a thing which was founded way back into 1950s. ML came a bit late, and then deep learning came in 2010. So this is just the timeline that you have gone through. Big data is almost certainty uses machine learning for the second question. It almost certainty uses machine learning. AI may or may not be used, because if you have data, you need to analyze it. So you have to have certain tools into it. Either it has to be AI or it has to be an ML. Mostly for the oil and gas product that they too have discussed, it is principally an AI. In certain cases of Honeywell, it is machine learning too. Last one, it is a problem to qualify for a big data related solution. We need to classify the problem in 6 subset detailed discussion that we have different slides. So why we need these basics, right? This is very critical to understand to all of us. All of us, when I say that is EHS fraternity back in India, right? So the reasons are quite simple. To identify the problem and create correct use cases, perspective, correct use of technology and combination. We are just curious. Actually, we are just curious to technology. We must use technology, but we must define what is supposed to be used for our kind of cases. To streamline our thoughts beyond over-enthusiasm to adopt new technologies, to lead your problem statement and not to follow, there is spell mistake, not to follow with sales approach of sales-focused vendor partners like us. We can come to you and sell anything that we wish to. But then you have to have your own query set ready that this is what we want. Doing justice to your organization funds, where you put your money. That's a very critical question that your management will ask someday. And most importantly, to model and draft accurate use case. That means where, how, when that technology has to be used, and what is the delivery set and the results you are looking at. This is a timeline of technology that has gone. AI came in 1952, actually. Then machine learning came around 80s, and then most recent is deep learning in 2010. The key differentiation between artificial intelligence and machine learning, I'll not go through these things. It is, in a nutshell, artificial intelligence is something which you train your computer once. Sorry. You train your computer once, it understands that, and keep on operating the same way. Machine learning, on the other side, learns once from the data set and keeps improving itself from the data set that it gets, maybe from the sensors, maybe from the other data sets. You can manually put in those data. So AI is something that you use in your Google Photos. In Google Photos or in all the new iOS or new OS, it understands you, right? It knows you, this is the face that Pawan is, so it will unlock my phone. But at the same time, if I grow my beards, still my phone understands that this is Pawan, that is ML, right? So this is the difference between AI and ML. So if you go to the lower version of mobile phones, that is using AI, whereas if you go to a good quality phone, it is actually using ML. It understands when you have sunglasses on, when you have beards on, that goes into machine learning. Those applications are PSM based. I'll take a case of PSM later on. I tried to draw something. It has gone a bit complex. But the right-hand side, artificial intelligence is a scenario analysis, human judgment, prediction output. The same artificial intelligence can use the insights from machine learning. The same AI can use artificial intelligence and insights from deep learning and any physical data input that you can do. So principally, at the end, before the output, mostly you're using AI, but before AI, you're using a lot of tools, which is using deep learning and machine learning and big data, maybe, right? Now the question is, the Honeywell presentation said a lot of data, a lot of sensors. So now, as in India, are we ready with those data? In the first session, when most people were talking about, they talked about availability of data. Our experience is typically bad in India for having a data set ready at the client side. You cannot find an SLD, you cannot find a layout at the right time. Forget about data of volume, flow, measurements. It is too tedious to have those things. The first thing, as an end user, we must know that what data we must store in what format and in what way. So the thing is, which data needs to be recorded? Where is the data in your facility? Data sample aging, what sample size you're going to train your AI model or the machine learning model, that aging, what number of years of data that you need to put into it, and then future agile data, how fast you can feed those data from sensors or manually. So forget big data if you're going to do it manually. So it will be mostly AI if you do manual data interpretation. One of the real-time example of AI is when I use a Google map in the morning. This is a 5:20 or maybe 5 a.m. screenshot. It says 42 minutes from my home to office. At the same time, this is AI. Computer knows this is a route from this is the home place of Pawan and this is office. It just finds the shortest route depending on the kilometers. This becomes AI. The moment at the same time, I ask the computer or the Google servers, please tell me the prediction that at 9:30 a.m. or 9 a.m. when I actually start for the office, what kind of prediction that I get for number of travel hours. That goes into machine learning. It learns from the data, a lot of data that Google collects from everyone's phone. When you travel on the same route, that goes into machine learning. Now, start thinking in that direction where you can use these simple thoughts into your own production and maintenance and integrity of assets. I'm just here to put the thoughts in, right? Rest is up to you. So this is a screenshot at 5:19 a.m. today morning, and I was able to see a timeline or the predicted traffic at 9 a.m. Right? So this is a prediction through machine learning. Now a small screenshot on the big data and ML. So primarily a big data takes a lot of data from data warehouses. Data warehouses maybe from sensors, your logbooks, a lot of data feed into it. Segmentation, it refines that what kind of data you are actually going to use and which is the useful data and what is not the so useful data. It filters. It further goes into extraction of groups. Don't go into technology, this detail of this, only understand there is a data and that is distributed into 3 components, predictive, descriptive, and prescriptive. If there is no missing values and it is a true data, it will go into predictive analysis. What it will do, it will train our existing formula of prediction to much refinement. So it's every time I feed in data, it learns from the same data, okay, this is the right formula. Like we have learned Pythagoras theorem in our classes, but there is no formula set yet ready to do any machine learning or any of the big data analysis. So you have to develop those formulas every now and then. So that prediction is automatically generated by computers from the data set that you get, right? So if any vendor comes to you and tells you that, okay, fine, I have a big data software, I have a machine learning, a deep learning software, then ask them, from where did you train this model? What is the formula that you're using in the backend? If you don't train that software from your own data, what is the probability that you get the actual results and feedback? So that is a question that, as an India Inc., we should ask all the vendors that is coming to us. So it is very important not to buy a software, but to deploy a software in the right way. Deployment matters. It is never about putting your money in buying softwares. That way, wrong input will definitely give you a wrong output. Then if the data is not that true, then it goes in descriptive analysis. It gives you some feedback, but doesn't change your formula and never learns about that. In the same way, it goes for, if it is very much right, it defines the fitness function, that is the formula again. It keeps on changing the formula. So that is the way when you see the media or the bigger AI companies, they predict who is going to win the election by looking at your Facebook post. They're actually using the millions and billions of bytes to analyze and predict and keep changing the formula basis behavior of ours. In the similar way, this can be used for PSM. We'll show you the case. Now, a big data depends on 6 factors. The first is volume, how much data you are going to use. Second is velocity, how fast that data comes to you. This is very critical. I can consume EB data in a year, but I cannot consume exabyte data in a day. So there comes computing. Then comes variety, that what kind of different size and formats. Suppose in oil and gas industry, if you're going for drilling operation or as say the exploration thing, you have a lot of data coming in. You have seismic data, you have simulation data, you have actual drawing data, you have actual manual feed data. Those goes into a lot of velocity, a GB per minute maybe. So you need to consume those data. You cannot consume yourself, so that then you need big data computing or ML computing. Then comes veracity, that is pulling of useful data from that much of bulk of data. What is right data? That is being learned by the computers. Then comes the value. Value is about the ROI, that you have purchased something, but what you wanted to get, and are you getting those things back to your company? Then the last one is the complexity. You need to find the real problem that you want to solve. Don't go for technology just to go for a technology. Find the problem, define the results, prove it to the funds that yes, the fund utilized has been delivering the results that we wanted to deliver. Now coming to EHS and PSM. As an end user community, we all are end user community. We need to reuse the discussed components to identify a problem statement, create a use case, define which the technique fits into your case, freezing correct RFQ for the vendor partner. So the agenda that you should take out from this presentation is, You start defining your problem statements. You will create a use case. You will define the techniques that you want. You want AI, you want a machine learning, you need a big data, and then freeze your RFQ to the software provider that this is what we need. This is the way we want it to deploy. This is the way we want to train our model. The journey in general starts with project identification. A life cycle projection, in general, 2 to 3 years is a life cycle projection. It goes for first year implementation as a prototype. You learn from it. And then assurance. Assurance is done to prove that you're actually getting what you were supposed to get. And then you implement for the rest of the 2 years the different projects of these size and shape. So automation of MOC is one thing that we are working with the CCPS guidelines that we are internally reading and using. So that is the one thing that we are internally doing. We are developing one of the most advanced softwares, which will be very much cost optimized and extremely deployable to your locations. Typical life cycle is ideation, prototyping, development, and integration. Then comes provision and deployment and integration. That is the most difficult thing to do. The reason being, you need the whole team to understand that what you're going to deploy. Who are the user? What everyone in your team is supposed to do, how they're going to use it. Then comes use case development. It is about identifying the key process problem, such as learning from multi-site factories, improving MOC process. We were working on a PSM project in Indonesia. We got to know that they have 17 different factories across the globe. Then I have the same process running across 17 different countries and 17 for the same process. Then do we learn from the MOC data? Do we learn from the MOC data being used for other 17 sites? That is where your data comes into play, and that is where the machine learning and AI comes into play, where the software tells you that the MOC is not required. Actually, it is a RIC. RIC is replacement in kind. So those learnings has to be used into PSM. I'll cut it short because the time has gone. So now we analyze the condition which is required to ascertain whether RIC is applicable or not for hardware, software, chemical, procedure, and people and supplier. So we have made ready-made tools to analyze this. Then the MOC goes for data availability, all the data in SQL, retrieval of data sets, preparing an algorithm, then an existing MOC model data in sets of learning, training the model, model testing approval, and training implementation. It can utilize industry 4.1 input, 4.0 inputs, depending upon the data. AI, ML, or big data can be considered. If you have a simple PNIDs, a machine variation, AI shall work. Complex PNIDs and a lot of operation variations, you need to go for ML. If a data is huge, like kind of drilling and exploration, you have to go with big data. Few of the cases, IoT-enabled, just 2 minutes, IoT-enabled fire system status and maintenance. There is an IoT-enabled AI model that we have developed. We have emergency response where we know exactly that how many people are stuck into emergency condition at what locations, so that you can prioritize your evacuation. Electrical failure and fire protections. Visual AI in storages. You keep storing things in your factory, and then you forget what you have stored where. And these are the live auditing tools, which can audit your factory 24/7. And the last one is the road safety for your colleagues. This is an app developed for using AI and ML. So that's it from my side. I hope we have done justice to your time and journey. Thank you.